Okay, so here is our third example of finding the domain of a function represented by a graph. So we're pretty well skilled at finding domains from graphs by this point. So you probably know pretty much what you want to do. You want to sort of scan the graph here from left to right and look at the extent of the graph along the x-axis here from left to right. Now, because of the way this graph is drawn, it's going to be very tempting to think that the domain of this function would start at -5 on the x-axis. It's very easy to think that that's the first number that we can use as input to the function that will give us a meaningful matching output value, up to about 10 on the x-axis. It looks like maybe that's the last input number we could use that would give us a meaningful or a real number output value from the function. But now that's misleading. One thing you've got to notice about this particular graph is that it is not explicitly terminated on the left with an open or closed dot, and it's not explicitly terminated on the right either with an open and closed dot. So that means that we have to assume, although we can't see it in the graphing window, because we can't graph, in a graphing window all of the x-axis or all of the y-axis. So even though we can't see it in the graphing window, we have to assume, because the graph is not explicitly terminated on either the left or the right, we have to assume that the graph is going to continue indefinitely on the right, and that also the graph is going to continue indefinitely on the left. So what that really means is that instead of the domain of this function just being from -5 on the x-axis to 10 on the x-axis, in fact, the domain of this function extends all the way out to -infinity on the x-axis and all the way up to +infinity on the x-axis. So in fact, the domain of this function, rather than being restricted, is really all real numbers. So that's sometimes confusing to students, that the domain of this function really is all real numbers, even though you cannot see the graph extending all the way to +infinity on the right or -infinity on the left. But that's what we have to assume because of the way the graph is drawn. Again, it's not explicitly terminated on the left with an open or closed dot, not explicitly terminated on the right with an open or closed dot. Now, you can write out this domain, all real numbers, just in words, and that's probably the best way to write it out, is just using words. You can also use some sort of bad mathematical grammar, some slightly improper mathematical notation, and write this as an inequality, although that's not the preferred way of doing it. So you could say that our domain extends or includes all real numbers greater than -infinity, and then also all real numbers less than +infinity. So you can write this as an inequality, but that's not quite proper mathematical grammar to write an inequality that includes negative and positive infinity, since these are not in fact real numbers.